Hello class. So we're going to be looking at the factoring questions, all 57 of them. So I hope you guys are excited. Let's try to get started here. All right, the first question. First question was 12p q squared minus 3p squared. Now, then in this case, as you can see, 3p was common factor, so we can factor out 3p. Then we have 4q squared is left from the first one minus p. And there's no other factor, so that's about it. That's how we can do first one. Alright, then let's move on to second one. Second one, it goes 63 x squared w plus 28 x w squared. Now, then in this case, what is the common factor? That's right, 7 is common, and x is common, and w is also common. Then when you factor out 7xw, you will realize that here, first one, 9x is left. From second one, plus 4w is left. And there's nothing else which we can factor from here, and that's it. That's our answer. Number 3. (32) b to the 5th power minus 12 b to the 4th power plus 48 b to the 3rd power. Now, then what is the common factor out of all these? 2 is common, but how about 4? 4 seems to be a better choice. And how many b's? B to the 3rd is all contained in all 3 of them, so b to the 3rd power. Then we have 8 b squared is left. Now second one is minus 3 b is left. And then the last one becomes plus 12 is left. Alright, then there is no other common factors. Now then, can you somehow simplify this one further? But the thing is, this one has to be same sign and then get negative 3. In other words, factors of 8 has to multiply to factors of 12 to produce negative 3. And no matter whatever factor you multiply to here, it is impossible for you to get negative 3 as a factor, because the fact that this last sign is positive, that means the sign of the factors of 12 has to be same sign. Even if both of them were to be negative, when you multiply them, you will get the number that's greater than 3 or less than negative 3. Alright, so this will be our answer for number 3. Let's go for number 4. 8a squared minus 6a to the 3rd plus 12a to the 4th. Now then, here it seems 2 seems to be common, and then a squared. So what if you have 2a squared? Then what's left here is 4 here, negative 3a, and then the last one seems to be plus 6a squared. Now then, same story as the previous one. There's no other way for us to get negative 3 as the middle number when you multiply the factors of 4 and the factors of 2, because they have to be all the same sign. So therefore, this becomes our answer. Number 5. X squared plus 5x plus 6. This one should be quite easy for us, because I mean these are the things that we've been doing all along anyway, since when you're in Algebra 1. So 3 and 2 is the factor here, so we have x plus 2 times x plus 3. Let's go for number 6. A squared plus 3a minus 4. So which two numbers multiply to negative 4 but add up to 3? That's right. If we have a plus 4 and a minus 1, then we'll be able to get this answer, number 6. Alright, let's move on. Number 7. C squared minus 4c minus 12. Now, which two numbers multiply to negative 12 but add up to negative 4? Yes, c minus 6 and then c plus 2. That's it. That's all we need. Number 8. U squared minus 20u plus 51. Which two numbers multiply to 51 but add up to negative 20? 51 is made out of 3 and 17, so in fact we'll end up getting u minus 17 times u minus 3. Then that's exactly what we end up getting. Number 9. H squared minus hk plus minus 2k squared. Now here you will realize that h squared, that means h is in both cases, k squared, therefore we have to have k. But negative 2 has to be somehow multiplied to, two numbers have to multiply to negative 2, which are the coefficients of k, but add up to negative 1, which is coefficient of hk. Now, then obviously that is negative 2 and positive 1. So that becomes our answer. H plus k times h minus 2k. Number 10. M squared minus 4jm plus 3j squared. So this is the same idea as before. So we're going to have m and j somehow. M and j. Now all you have to do is which numbers multiply to 3 and then add up to negative 4. In fact, it'll be negative 1 and negative 3. Those two numbers multiply to positive 3 but add up to negative 4. So there it goes. Number 11. Six y squared plus y minus 1. Now this one is we have to realize the factors of 6 somehow multiplied to factors of negative 1 get you 1 in the middle. That's one way that's possible is this, because one of the factor is what, 3 and 2. So if you have 3y and 2y, and the fact that we have to have negative 1 as the answer, that means one of them has to be positive 1, the other one has to be negative. But since their sum has to be positive, so we gotta have positive 1 over here, then 1 times 3 becomes positive 3y, and negative 1 right over here, so negative 1 times 2y becomes negative 2y. So there it goes. When you add them up, we get positive y. Number 12. Here we have 18k squared minus 9k plus 1. So which two numbers multiply to 18? And one is obvious, it's 1 and 1, but add up to negative 9. And in this case, we could have 6k and then 3k. But the fact that it's negative, that means both of them has to be negative 1 to make that into 6k and then negative 3k, which ends up being negative 9k when you combine them together. So that becomes our answer. Number 13. Then from here, 8x squared minus 14x plus 3. Which two numbers can multiply to 8, and then which two numbers multiply to 3 but add up to negative 14? Let's try. Maybe 1 and 8, or 2 and 4. And then 3 becomes simply 1 and 3. That's only one choice. So 1 times 1 and then 8 times 3 becomes 24. And one way or the other, 1 and 24 wouldn't make 14. Let me try to go for the other way around. 1 and 3 and 8 and 1. That doesn't also work either. 1 and 3 is 3 and 1 and 8 is 8. They don't add up or subtract to negative 14. So first one is out. How about second one? 2 and 1 and 4 and 3 becomes, oh wait a minute, this is 2 and this is 12, so they can add up to negative 14. The fact that 2 and 1 has to multiply together, that means our answer would have been 2x has to multiply to 1 and 4x has to multiply to 3. And they have to be in the other parentheses. Now since both of them has to be positive, that means it has to have same sign, but they add up to negative, so both of them has to be negative 1 and negative 3 as the factors, along with the 2x and 4x. Number 14. here we have 12 t squared plus 5t minus 2. Then, once again, just like before, we are looking at the factors of 12, such as 1 and then 12, and 2 and 6, and then 3 and 4. And negative 2, basically 1 and 2, and somehow we have to get 5. How can we get 5? So you can examine these numbers, 12 and 2, and then, 12 and 1 and 1 and 2. Whether you multiply 12 and 2, it doesn't quite cut it. Wait a minute. If you look at 4 and 2, that becomes 8 and then 3. So if you multiply these two and these two, 8 times 2 becomes, 4 times 2 becomes 8. 3 times 1 becomes 3. And then if you have to subtract them, you'll get 5. So, and that's exactly what we're looking for here. So this becomes 3x and 1 has to multiply together, and 4x and 2 has to multiply together. But we have to get positive 5. That means these two has to multiply to positive number, and 3x times 1 has to be negative, subtracting. So therefore we get 3x plus 2 times 4x minus 1. So as you can see, inside becomes 8x, outside and outside becomes negative 3x. When you add them up, we get 5x, or 5t in the middle. Let me just write down t instead of x. Sorry about that. T, 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 t. All right, let's look at number 15. V squared minus v minus 35. So let's think about that 1 second. This basically means 1 and 12, 2 and 6, and 3 and 4. As you can see, there are many factors. But 3 and 5, that means what? 35, that means 1 and 35. And then 5 and 7. You see, the difference somehow has to be equal to negative 1. That means we are looking at sums that are, or products that are rather close to each other. So when you look at it, one thing that's possible is this. You see, if you multiply 3 and 7, we get 21, and then 5 and 4 becomes 20. And then you can subtract it. In other words, you could have 3v multiplied to 7, and then 4v multiplying to 5. Then this becomes 20, and this becomes 20v, and that becomes 21v. But to get negative 1, that means this one has to be negative. So negative 7 and then positive 5. That becomes our answer. All right, number 16. So here we have 12 u squared plus 47u plus 40. Now, you can see that there are many factors here. So you have 1 and 12, and 2 and 6, and 3 and 4. And 40 becomes, you have 1 and 40, and then 2 and 20, and 4 and 10, 5 and 8. So we have to get somehow 47. How can we get 47 here? So basically we are looking at (1) and 12. Can I match them with this one? I think that's a bit too much. We have to get 47, so that means we can then multiply by the two even numbers. Not for this one either. How about this one? This one is 5 times 12 becomes 60, and that's not going to cut it. The other way, no. This one doesn't work. How about 2 and 6? Let's try looking 2 and 6. 2 and 6 here becomes 2 times 40. The 40 makes a bit too a bigger number. And then can I get 47? Okay. So how about 2 and then 2? Or even number times even number will always get even number no matter what. So it cannot be odd number. Same thing for here. Then how about this one, the last one? These are two even numbers. Multiply 2. Whatever numbers, you will always get even numbers. So it cannot be 47 either. Let's go for the last number. Here, 3 times 5 becomes 15. and 4 times 8 becomes, that's right, this one works. So 3 times 5 can multiply, 4 times 8 can multiply. That means we have 3, u has to multiply to 5. And then 4u has to multiply to 8. All of them are positive, so I can easily put positive and positive, and that becomes our answer. Number 17. (28) z squared minus 5z minus 3. Let's look at it. Then what are some possibilities? 28 is 1 and 28, 2 and 14, 4 and 7, and 3 is simply 1 and 3. That's it. Somehow we have to get 5 in the middle. How can we get 5? I want to look at it carefully. That's right. This one and this one. 4 times 3 is 12, and 7 times 1 is 7. So 12 minus 7 becomes 5. That's right. So here we get 4 has to multiply 2. So 4z has to multiply to 3. And then 7z has to multiply to 1. This one is 7z, while this one is 12z. And since we have to get negative, that means whatever is bigger has to carry the negative sign, and this one is positive sign. So therefore this becomes our answer. Number 17. Number 18. (2n squared minus 13n plus 5). Now here, what will I do so that I can get 13n? Wait a minute, maximum will be 2 times 5. That will get you 10, and the other one will be 1 and 1. There's no way for us to get 13. Maximum will be 11. So therefore this cannot be done. Makes this one to be prime expression. Alright. Number 19. (16y squared plus 8yz minus 3z). Now here, even though we have z and z squared, it doesn't really matter. We just have to play with the numbers here. Same way as before. 16 gets you what? 1 and 16, 2 and 8, and 4 and 4. How about 3 is simply 1 and 3. How can we get 8? That's right. In fact, if you multiply, 4 times 3 becomes 12, and then 4 times 1 is 4. When you subtract, then you will get 8. So in other words, 4y, because first one is with y, and then something has to do with z. 4y has to multiply to 3z. That makes the other one is 1z. And then 4y has to multiply to z here. And here we get 4yz, and here we get 12yz. Now, we're looking for positive values, so this one has to be positive while this one has to be negative. That becomes our answer. Number 19. Number 20. (6g squared minus 23gh plus 15h squared). Now, so once again, let's play with the numbers. 6, that means 1 and 6, or 2 and 3. 15 is 1 and 15, and 3 and 5. Can we somehow get 23? Let's see. 6 times 15, oh, that's way too big. 6 times 1, that's 21. So that's not going to cut it. And then 6 times 3 becomes 18. Oh, wait a minute. 1 times 5 is, that's right. So 6 can multiply to 3, and then 1 can multiply to 5. That means 6g, and then 3h. And here, g, oops, my bad, 6, g has to multiply to 3, so therefore we have 3h here. G has to multiply to 5h. Now, both of them are positive, and then while the middle term is negative, that means both of them has to be negative sign. Number 21. P squared minus 18p plus 81. Notice, wait a minute, this can be easily done with p minus 9 and p minus 9. That's it, very simple. 22. B squared plus 12b plus 36. Oh, wait a minute, this one seems to be also two numbers multiplied 36 add up to 12. In fact, that's equal to b plus 6 squared. Notice that whenever it's a perfect square, the half of the middle term is equal to half of the middle term is the square root of the last number, or in other words, half of the middle term square that becomes the last number. That is the perfect square, and that's what we have seen from two questions here. Number 23. Four y squared plus 20y plus 25. Notice that we can try to go for factors of 4 and then factors of 25, but did you realize that those are all perfect squares? Then chances are that we might have 2 and 2 and then 5 and 5. Then we get 2 times 5 becomes 10 and 2 times 5 becomes 10. Hence, no wonder we get 20y. Then this in fact is equal to 2y plus 5 square. Let's look at number 24. (81z squared, aha, it's a perfect square, minus 36z plus 4. Wait a minute, can it go for 9 and 9 and 2 and 2? 9 times 2 equals 18 and 9 times 2 equals 18. 18 plus 18 is in fact 36. So basically what we have to do is 9z plus 2, or rather minus 2. And then 9z minus 2 would have been our answer for this trinomial factoring. Number 25. K squared minus 64. That means this is difference of squares. We will end up getting k plus 8. Square root of both of them, and then k plus 8 and k minus 8. That's the factoring of the difference of squares. Number 26. Here, 9n squared minus 121. If you didn't notice, in fact, 9n squared is in fact equal to 3n. Entire thing squared minus 11 squared is equal to 121. That means this is difference of perfect squares. So therefore we get 3n plus 11 times 3n minus 11. And that becomes our answer. Number 27. U squared plus 4. In fact, how'd you do this one? U squared minus 4 would have been very nice, but U squared plus 4 is quite tough. There is no common factor, and there's no way for us to factor this one. So in this case, we'll get prime. So because if you have to think about it, which two numbers multiply to 4 but add up to 0? That's not possible. So number 28. Here, 25x squared minus 100y squared. Once again, perfect squares, which is 5x squared minus 10y squared. Then, here we get difference of square is 5x plus 10y times by 5x minus 10y. We call it conjugate pair. Number 29. Number 29 is y cubed minus 27. In fact, this is the difference of the cubes. But in class, what we have done was we talked about the sum of the cubes. So why don't I just rewrite this one as the sum of the cubes? This can be rewritten as y plus negative 3 to the third power. And that is, in fact, sum of the cubes. Just for your reminder, sum of the cube formula is a cubed plus b cubed is equal to a plus b. We proved this one in class. A squared minus ab plus b squared. Now, then what's going to be happening? When you factor this one, first one is same as they are without the exponent. So we have y plus negative 3. And then the first one square, which is y squared, minus a times, which is y, times negative 3. And then the last one is plus negative 3 entire thing squared. Then here we get y minus 3, y squared, plus y, and then plus 9. That becomes our factoring of the difference of the cubes. Number 30. Number 30, a cubed plus 8 is in fact equal to a cubed plus 2 cubed. Now, that means a plus 2 is the first factor, and second one is a squared plus 2 times, plus first one times the second one, which is 2a, and then plus the last one squared, which is equal to 4. And as you notice that this cannot be factored anymore. So that's the answer. Now, let's look at number 31. (27v to the third power plus 125). In fact, this is the same way as before. Here, 27v to the third power is simply 3v entire thing cubed plus 5 cubed. Then using the formula, we get 3v plus 5 is the first factor, and second factor is 3v squared, which is 9v squared, and opposite sign, which is minus the product of those two, which is 15v, plus square of the last one, which is 25. And as you can see, this one cannot be factored anymore. So therefore, this is answer. Number 32. (8 r cubed minus 64k cubed). If I were to rewrite this one as sum of the perfect cubes, then we get 2r entire thing to the third power plus negative cube root of 64 is 4, because 4 times 4 times 4 is 64, or negative 4 times negative 4 times negative 4 is equal to negative 64. And then k to the third power. Then here it goes. We get 2r plus negative 4k. And second one is 2r squared, which is 4r squared, plus, or rather minus this one times that one, which end up getting 2r times negative 4k, and then square of the last term, which is equal to 16k squared. Now, if you have to simplify this one further, what we end up getting is 2r minus 4k times 4r squared plus 8rk plus 16k squared. And that becomes our answer for number 32. 33. (16 n to the fourth power minus 1). So this can be done by the difference of two squares. We end up getting 4n to the fourth of 4n square minus 1. Then this in fact becomes 4n plus 1 of 4n squared plus 1 times 4n squared minus 1. Now, in fact, you will realize the first one is already done, but second one can be factored further because this is once again difference of squares. So here it goes. We get 4n squared plus 1 times 2n plus 1 times 2n minus 1. And that becomes our answer for number 33. Let's go for number 34. So here we have 16u to the 4th power minus 200u squared plus 625. In fact, did you notice that first term and then last term are perfect square, 16 and then 625. So our suspicion was, okay, then what if you had to go for simply 4 and 4? And here we get 25 and 25. Wait a minute. 4 times 25 is which is equal to 100, and both of them can get you 100, hence matches with the middle term. Then this number, this question now becomes 4u squared 25 and 4u squared and 25, and then since the middle term is negative and then the last term is positive, so we end up getting negative and negative. But we're not done yet because you have to realize that the 4u squared is a perfect square and then 25 is also a perfect square, so this becomes 2u plus 5 times 2u minus 5. But the same thing happens 2 times, so we can just simply put down the squares on both of them. That becomes our answer for number 34. Number 35. Four x to the 3rd power plus 24x squared minus 64x. Now here you will realize that 4x is common, so if you have to factor out 4x, then we get x squared plus 6x minus 16. Now, then which two numbers multiply to 16 would add up to 6? That's right. This can be further broken down into x plus 8 and x minus 2. Those two numbers multiply to negative 16 but add up to 6. And that becomes our final answer. Number 35. 36. 3a to the 5th power minus 300 a to the 3rd power. Now what is the common factor first? Yes, 3a to the 3rd power. Then we are left with a squared minus 100. But you can factor this one further because 100 is a perfect square, so is a square. Then here we get 3a to the 3rd power and then a plus 10 and a minus 10. And that becomes our answer for up to number 37. Alright, great. So let's continue from here. Alright, so number 37. N to the 4th power minus 2n squared plus 1. Then here, in fact, which number multiply to? 1, but add up to negative 2. In fact, that is negative 1 and negative 1. But the thing is, this doesn't seem to be quadratic, but I have n to the 4th power. But if you have to think about n to the 4th power carefully, that's n squared. In other words, this can be rewritten as n squared minus 2n squared plus 1. That means we can factor this one in 2. N squared minus 1 times n squared minus 1. Because it's a perfect square. But n squared minus 1 is not done, so we get n plus 1 and minus 1. Because that's the difference of square, and then we have 2 of those, so we can just square both of them. That's number 37. Let's look at number 38. So 21 j squared plus minus 57 jk minus 18 k squared. Now, which two numbers multiply to 21? So we have 1 and 21, and 3 and 7. Here 18, we get 1 and 18, and 2 and 9, and 3 and 6. So how can we multiply them together so that we can get 57 out of it? Now, first set, 1 and then 21 doesn't seem to be fitting correctly here. How about the other way around? 21 times 2 becomes 42 times plus 9 becomes 51. So it doesn't work. How about the next one? This becomes 21 times 3 becomes 63. Oh, wait a minute, 63 and 6. Haha, they match. Because 21 multiplied to 3. But we have 3k. And then 1j multiplied to 6. Okay, then let's see what happens. Here we get 6kj. Here we get 63kj. If you have to subtract those two, then we will end up getting 57. So that means the fact that we have negative sign over here, then this one should be negative, this one should be positive, and that becomes our answer. Number 39. B to the third power plus 62b squared minus 72b. So here it seems to be 4 is for the common, no, just 2. So why don't we factor out 2b? Then we have 8b squared plus 31b, and then minus 36. Then let's see. Let's look at the factors of 8 and factors of 36, and then try to make 31. So 8 becomes 1 and 8, 2 and 4. And that's about it. How about 36? 1 and 36, 2 and 18, 3 and 12, 4, 9, 5, 6 and 6. So how can we get 31? Let's look at it for a second. So 1 and 8 cannot be combined with 1 and 36. Now, how about the second one? One and 8, can it be combined with 2 and 18? Not quite. Now, third one doesn't work. The fourth one doesn't seem to work either. Fifth one doesn't work. Let's look at 2 and 4. But in fact, in order for us to get 31, as a factor in the middle, only way that's possible is one number is even number, the other one is odd number. So 2 and 4 cannot be the factor that's given. Let's try to examine 1 and 8 one more time. One of them has to be odd, the other one has to be even to get odd number. So even doesn't work. Even doesn't work. So we have three options. 1 and 8. Can they somehow multiply to 4 and 9? 32 and then 9. They don't get you 31. 1 and 8, which is 8, and then 12, it's a very large number. 8 and that doesn't work quite either. So, in fact, it seems like none of them works. So I just leave that as it is, right over here. Alright, now, let's look at number 40. X to the fourth power minus 13 x squared plus 36. Here, that means which number can multiply to 36, but add up to 13. In fact, when you look through that, this one, what if I this one is almost like a perfect square, where if I have x to the fourth minus 12x squared plus 36. This should have been perfect square, but we have one more extra negative x. So what if you had to put that into x squared over here? Then in fact, one thing amazing happens, that is, if you had to factor this one, you will get x squared minus 6 squared, but minus x squared. You will get a difference of perfect squares here. Then here, what we end up getting is x squared minus 6 plus x, that's 1, x squared minus 6 minus x for the second one. But can this be factored further? In other words, let me just rewrite it. X squared plus x minus 6. I can write it in that way here, x squared minus x minus 6. In fact, this can be factored into x plus 3 and x minus 2. That gets you this first expression. Second expression, in fact, would be exactly the same except x minus 3 and x plus 2. And that becomes our final answer, number 40. Number 41. (16z to the third power minus 250). Here then we end up getting 2. Then we have 8z to the third power minus 125. But this is very nice because this is a difference of perfect cube. So I can rewrite this one as 2, and here we get 2z to the third power plus negative 5 to the third power. Then we get sum of the perfect cubes, which we have learned in class. Then here I'm going to put 2 as it is. Then we get 2z minus 5, and then 2z squared, and then here we get minus negative 5 times 2z, and then the last one squared, which is equal to plus 25. Then if I have to rewrite this one, we'll end up getting 2 times 2z minus 5 times 4z squared plus 10z plus 25. Now, can we factor this one further? No. In fact, 2 and then 5. Then we'll be needing 20z, and then none of the options will work. So this becomes our final answer. Number 42. (56x cubed y minus 70x squared y squared plus 21x y to the third). So here, in fact, what if you had to factor out xy altogether? And then is there any other numbers that are common? No. So if you have to factor out xy, then we get 56x squared minus 70xy, and then plus 21 y squared. Now then here, can we somehow manipulate the numbers between 56 and 21 to get 70? Then let's try to look at the factors here. 1 and 56, 2 and 28, 3 and 4, 4, and then 14, and then 7 and 8. 21 is 1 and 21, and then 3 and 7. I want you to examine the numbers. How can we somehow multiply so that we can get 70? So here 1 and 56 doesn't seem to work with any one of them. 2 and 28. Oh, wait a minute. 2 and 28 may be okay because 2 times 21 and 28 times 1. Because 2 times 21 becomes 42 plus 28 becomes 70. Alright, so our answer would have been xy. And then 2, x has to multiply 2. 21y. And then 28, x has to multiply 2, y. But both of them has the same sign, and add up to the negative, then these are negative sign. That's basically what we end up getting. Alright, number 43. Five x squared plus 180. Then 5 is common factor. Then we have x squared and plus 36. And in this case, can we factor this one any further? It's a perfect square. It's a plus sign. It's not negative sign. And I guess that's it. That's all we can do. Let's look at number 44. Nine x cubed y plus 12x squared y squared plus 4xy cubed. Similar to the question number 42, I believe. We can factor out xy first. Then we get 9x squared plus 12xy plus 4y squared. Now, then here we have xy. Then what do we end up getting? Oh, wait a minute, this is perfect square, this is perfect square. So in fact, what this one ends up being is 3x plus 2y times 3x plus 2y. Then you can see that 3x times 2y gets you 6xy, and then we have 2 of those. Therefore, we get 12xy. And that becomes number 44. Let's look at number 45. Negative 243 x cubed plus 216 x squared minus 48x. Here, one of the first things which we can factor out seems to be x and also maybe 3. Why don't we factor out negative 3 then? Negative 3x. Then we get 81 x squared, and plus we get 72 x, and then the last one, actually it has to be negative. It's factoring out negative sign. Here last one it becomes plus 16. So then these are the perfect squares. Can we somehow put them together to be 72? Yes, because 9 and 4. In other words, this is negative 3x, and then 9x minus 4, and 9x minus 4 would have given you this one. Alright, let's move on. And 46. Here, x squared minus 3x plus xy minus 3y. Now, how can we factor this one? By grouping. If you're to, maybe group these two first. Then we get x, which is equal to x minus 3. And here we realize y is common, so plus y, then x minus 3. That means x minus 3 is common. So we get x plus y. That becomes our answer. Number 47. 12a squared minus 4ab minus 9a plus 3b. So let's try to break them down here. It seems to be 4a is common. So then we get 3a minus b. Here, negative 3 seems to be common. Then we get 3a minus b. And 3a minus b is common here in both cases. Then we have 4a left from the first term, and then minus 3 from the second term. And that becomes our answer. Let's look at number 48 together. Here, 12st plus 56r minus 96rt minus 7s. Now, then once again, just like before, let's just separate them. Here, well, what is common between 12st and then 56r? One thing that which you can do is maybe we can factor out but when you look through the next one, wait a minute, this one is r and r. Instead of doing these two, what if you had to group them these two, because both of them shares also r2 and here it shares s. So let's try to factor out here first. Then when you factor out s, then we have 12t minus 7. Now second one, so r is common, but not only r, 8 is also common to 8r. Then we'll end up getting here 7 minus 12 t. Now, but you realize that these are about the same except the sign in the middle, so that means what we can do is I can multiply by negative 1. This can be equal to s 12t minus 7, and negative 8r then becomes 12t minus 7. Since 12t minus 7 is common factor, then we end up having s minus 8r. Alright, let's move on. Number 49. (63h squared) plus 4k plus 3h at 36 h plus 7h k. Let's look at what's common. Here, when you look at it, we have h, h, h. H's are in 3 places, while k is in 2 places. So what if you had to group these two k's first, and then let these h's take care of them by themselves? So here, when you look at them, 7 and 4, nothing's common except k. So I'm going to factor out k first. Then we have 4 plus 7h. And here I realize that 9h is common. That means we have 7h plus 4. In addition, whether we change the order or not, it doesn't matter. So we realize that these two are common. That means 4 plus 7h. And what's left is k plus 9h. And that becomes our answer. Alright, let's go for 50. So p squared minus 4r squared plus 4p cubed plus 8p squared r. Wow, there are many things. P and r seems to be the common factor here. Now, but not only that, this is difference of squares, so one thing which we can do is, how about here, p plus 2r and p minus 2r. That's how we can factor them. Here what's common is 4p squared. So plus 4p squared. Then what's left is p plus 2r. Now, then what we end up getting is, since this one is common, so p plus 2r is common here, then what's left is p minus 2r plus 4p squared. And there is nothing else which we can factor, so that becomes our answer. Alright. Let's go for number 51. D squared minus 1 minus 7d squared f minus 7df. Then once again here we can do the similar one, d plus 1, d minus 1, factoring. Here minus 7df seems to be common. Then here we have d, and then this one is plus 1, factoring. Then once again d plus 1 is common. Then d minus 1 minus 7df. And that becomes our final answer. (52). (52) is 6c2x plus 8c to the x minus 64. Now let's look at this one carefully here. First, 2 seems to be a common factor. So let's factor out 2. Then we get, but we have c to the 2x and then c to the x. If you have to rewrite this one, then we end up getting 3 c to the x entire thing square. That's how we can have c to the 2x, you see. 2 and x multiplies together in this way. And then plus 4cx and minus 32. Then how can we multiply the factors of 3 and the factors of 32 so that we'll get 4. So 3 basically means 1 and 3. Let me erase the equal sign. 32 is 1 and 32, and 2 and 16, 4 and 8, and that's about it. Oh, wait a minute. 3 times 4 becomes 12, and 8 can subtracting it so that we can get 4. So in other words, so here it goes. 2 was already out there. 3cx has to multiply to 4. And then cx, c to the x power, has to multiply to 8. This get us 8c to the x power. This one get us 12c to the x power, but our sum has to be positive, then this will be positive, then makes this one to be negative. So that becomes our final answer. Let's go for number 53. Here we have a to the third power plus 2 square minus 100. Then what are we going to do? This first of all looks like a difference of 2 squares, so we're going to have a to the third plus 2 plus 10 times a to the third plus 2 minus 10. Interestingly, this one becomes a to the third plus 12, so that it doesn't mean much. This is already factored. But here we get a to the third minus 8. But 8 is the perfect cube. So this can be rewritten as a to the third plus 12 times a to the third plus negative 2 to the third power. then using the sum of the perfect cube formula, a cubed plus 12, then we get a plus negative 2 times a squared minus a times negative 2 plus square of this one, which is equal to 4. Now if I have to rewrite this one, a cubed plus 12, and here we get a minus 2, and here we get a squared plus 2a plus 4. And that becomes the answer for 53. 54. Okay, this is kind of long, so let's try to write it. S squared minus 2st, entire thing squared, minus 2t squared, and s squared minus 2st, and minus 3t to the 4th power. So here, you can consider this one as some number square minus 2t squared times that number minus 3t to the 4th power. So if you have to factor this one, which number multiplies to the last term would have been t squared, so that we can get t to the 4th power. And first one would have been the one in the expression, s squared minus 2st, s squared minus 2st. But somehow some of these has to have coefficients of factors of negative 3 and add up to negative 2. That's possible by having negative 3 here and positive t. Now, then in fact, then you will realize that we just have another two expressions here. We have s squared minus 2st plus t squared. Notice 1, 2, 1 with a negative sign in the middle. This is another perfect square. Here we get s squared minus 2st minus 3t squared. Then here what do we end up getting? This becomes s minus t squared. That becomes this one. Here we get s minus 3t times s plus t, similar to what we have done earlier with the same coefficients. Then I think we are done. Yeah, that was number 54. Number 55. So it looks like very complex, but let's look at it carefully. 2xk plus 4 power, w to the 4th power, minus 8 times x to the k plus 2 power, and w to the 4th power. Something repeats here, isn't it? Minus 10 x to the k power, and w to the 4th power. What repeats here? In fact, you will realize that the k repeats, meaning x to the k power is common factor. Not only that, w to the 4th power is also common, so as 2 in all the numbers. So therefore, I'm going to factor out 2x to the k power and then w to the 4th power. Then what's left? X to the 4th is left from the first term. From the second term, we have negative 4x squared is left. The last term, minus 5 is left. Then I'm just going to repeat the first factor. So when you factor this one, we'll end up getting x squared minus 5 and x squared plus 1. And that's about it. Yep. Number 56. Number 56 is actually quite interesting. U to the 18th power minus m to the 18th power. How are we going to factor this one? First, it looks like a difference of perfect squares, meaning this one looks like u to the 9th square minus m to the 9th square. Then in that case, we will be able to get u to the 9th plus u to the m to the 9th times here u to the 9th minus m to the 9th. Then here what we end up getting is this. This is also sum of the perfect cube, meaning u to the 3rd cube plus m to the 3rd cube, and the other one is u to the 3rd cube minus m to the 3rd cube. Then here, first one, if I have to do this one becomes, in this case, what I'm going to do is this. Here we get u to the 3rd plus m to the 3rd times u to the 3rd square, which becomes 6th power, and then minus u to the 3rd and m to the 3rd power. Now, the last one becomes plus m to the 6th power. That's the factoring of this one. How about this portion? Here we get u to the 3rd minus m to the 3rd, and then the rest of them becomes u to the 6th plus u to the 3rd, m to the 3rd, and plus m to the 6th power. Now, but we're not done yet, because here we can factor this one further. This one now becomes u plus m times u squared minus um plus m squared. And then this term becomes u to the 6th power minus u to the 3rd power times m to the 3rd power plus m to the 6th. And continuation, this one becomes u minus m times u squared plus um plus m squared times this one, which is u to the 6th plus u to the 3rd, m to the 3rd, plus m to the 6th power. And that becomes our answer. Alright, I hope you had fun. And then the last question. Last question was, here it goes, 2a to m power and minus am bk minus a to the m b to the k power, and then b to k minus b to k. Now you will realize that the I mean, this is quite it seems quite ugly. So what if you were to use the a to the m power as maybe x and then b to the k power as y? Then what you end up getting is this becomes 2x squared minus xy and then minus y squared. And this is rather simple because 2 and negative 1, in other words, we get, when you factor this one, 2x and x and y to get negative. This one has to be negated, this one has to be plus. Then we're going to get this expression But now, after that, all we have to do is substitute a to the m power and b to the k power. So here we get 2, x was a to the m, plus b to the k, and a to the m minus b to the k. And that becomes our answer. Alright, that's it. Have a great day, and I'll see you later. Bye-bye.